A thermometer, an apparatus which can be used to record the temperature, and it uses the basic principle that any physical quantity which changes with temperature can be used to design a thermometer. So what we can do, we can measure the volume of, or we can use the volume of liquid to design a thermometer, because the volume of the liquid changes with temperature. If you have a thermometer, this is a bulb of a thermometer, and the capillary is there. So it uses a concept of change in volume. As the temperature increase, the volume of the liquid changes, the liquid will expand and it will rise in the capillary. As the temperature decrease, liquid will contract, and the temperature, as the temperature decrease, liquid will contract. So level of the liquid in the capillary will decrease. So it uses a concept that the volume of a liquid changes with temperature. So we use it to design a thermometer. Same thing, what else can be changed with the temperature? Volume of a gas can also be used to design a thermometer. But you don't have to learn that in detail. Only one part which you have to go in detail is about the volume of the liquid and how volume of a liquid is used to design a thermometer. There are thermometers which use change in volume of a gas to record the temperature, but it's not part of the syllabus, so we'll not discuss. Just so you should know that the volume of a gas can also be used to design a thermometer.
Sir,
Yes.
sir, in the previous meeting, we were solving a question related to the air thermometer. Is
Yeah,
that an
differential.
example of how?
Yeah, that was example. Differential thermometer was example of volume of a gas, like this thermometer.
Okay, sir. Thank you.
So this is a differential thermometer. Actually, it is using a volume of a gas to record the temperature. It's also having a marking like how much change in volume occur that can be used to design, or find the temperature. But the thing is, because it's not part of syllabus, so I'm not going in detail of that. Just mentioning the points which can be used to design a thermometer. Same thing, as the temperature change, the pressure of the gas is also changed. As the temperature change, the pressure of the gas also change, which can also be used to design a thermometer. Resistance of metal. In block 4, you will study that resistance of the metals changes as the temperature change, which can also be used to design a thermometer. Or voltage across the metal can also be used to design a thermometer. So these are the things can be used to design a thermometer. Volume of a liquid, how volume of a liquid is used to design a thermometer, we discuss in detail. The other parts will not discuss in detail. Only the last one, introduction, will be there, but not in detail, like not all the things you will study about that. So for this purpose, what we use a thermocouple. But before thermocouple, you should understand the meaning of voltage. What's the meaning of a voltage? It is work done on unit charge, or in short, it is energy carried by unit charge. So how much energy one charge carry, that is known as voltage. Example, you have seen like you're using sockets, electrical appliances, devices, and on the socket it is written 220 volts. Unit of voltage is volts denoted by capital V. So what is the meaning of this volts? So the meaning of this volt, what it shows example, if I plug in a television, say this is television, and I plug in the television to this socket. So what is the meaning of this 220 volts? It means when I plug in, the charges start to move. The charges are moving through the wire, but how much energy when this charge is moving through the wire, how much energy this charge carry? This charge carry 220 joules. So 1 coulomb of a charge carry 220 joule. That is known as voltage or volts. So meaning of a voltage means energy which one charge carry or 1 coulomb of a charge carry. So when this 1 coulomb of a charge carry, this 220 joules it is carrying, when it enter, it transfer its energy to the television and the television will work. On the cell, it is labeled like the batteries or the cell, it is labeled 1.5. So what is the meaning of this 1.5? If it is written on the cell that it is 1.5 V. So what does it show? It shows if you connect a lamp, a small bulb, because 1.5 is not too much energy to, like you cannot use it to for working of a television. So small devices can work with this small voltage 1.5. So what does it mean? It means when one charge will come out, how, or one charge is moving, how much energy it will carry? It will carry 1.5 joules. So the energy which one charge carry, that is known as voltage. Is it clear the concept of the voltage? How much energy the charge carry, each coulomb of a charge carry, that is simply known as voltage. Any doubt in this part, the voltage? That is why, like example, if you touch a socket or a supply which is 220, no, joules is not equal to volt. Joules by one charge, like there is one charge. So how much energy one charge carried? So joules, like example, if I say 20 joules carried by one charge, unit of a charge is coulomb. So 20 joule per coulomb, that is called volts. So how much energy carried by one charge? So example, if you have a wire and there are 4 charges moving through the wire. And moving from point A to point B, they transfer or they take the total charges, they take 20 joules of energy. How much energy one charge will carry? What is the energy carried by one charge? If there are 4 charges, total they carry 20 joules. So each charge will carry 5 joule. So this 5 joule which is carried by one charge, That is called voltage. So we'll say that voltage is 5 volts. So there's a difference between so the how much energy carried by one charge, that's called voltage. Is it clear the difference between the two? Energy is ability to do work is called energy, but how much energy one charge carry, that's known as volts. If a charge is having a high energy, it can move faster, that can also happen. But if there is like too many charges, so it might move slower because of too many charges. So both things are possible, but the energy which one charge carry, that's called volts. Now, what is the main topic? Main topic is about thermocouple. So to understand thermocouple, you should have an idea what is the meaning of volts. So what is a thermocouple? A thermocouple consists of a voltmeter, millivoltmeter. A voltmeter is used to measure the voltage or energy which one charge carry. And it is made up of two different types of wire, two wires which are connected to voltmeter. We call that as a wire one. Wire one means they're same type, or wire A you can say. And the two wires which are coming out from the voltmeter are connected by another type of wire which we call wire 2. Wire 2 here refers to like another material is there. The point where the two wires will intersect, that is called junction. So thermocouple consists of a voltmeter. Normally it's a millivoltmeter, but you can mention voltmeter. The two wires, thermocouple. What is the purpose of the thermocouple? Thermocouple is also used to measure the temperature. It is also used as a thermometer, How we use thermocouple as a thermometer, I will explain this. Now what happened? It is made up of two wire one, which are coming out from the voltmeter, and wire two, which is made up of different material. And the two wires which are coming out from the voltmeter are connected by another wire, which is wire two. The point where the two wires will intersect, combine, what we call that as a junction. The position where we place a hot object, we call that as a hot junction. And the place or position where we place a cold object, we call that as a cold junction. So for thermocouple to work, there should be a hot junction and cold junction, like two surfaces should have a different temperatures. Now, which side will have more energy, hot junction or cold junction? Which side will have high energy or particle will have more energy? The hot junction, the particle will have more energy as compared to cold junction. So what happened? These particles, because these are metal wires, so the electrons start to move or the charges start to flow. The charges will flow through wire one, and the charges will also flow through wire two. But the number of the charges flowing through wire one and wire two will be different. Why the number of the charges? Because they are different material. So if they are different material, they have different capability to transfer the charge. So what this voltmeter will show, how much energy carried by one charge. Like as the charges start to move, the purpose of the voltmeter is show how much energy the charges carry. So example, this shows 3 volts. So how you will know the temperature by the voltage? So all these thermocouples have a scale like unit, like 1 volts stands for 10-degree change in temperature. When a thermocouple voltmeter show 1 volt, the 10-degree change in temperature is there. Means difference between the temperature and hot and cold junction is 10 degree. If it is 2 volts, the difference between the temperature of hot and cold junction is 20. If it is 3 volts, the difference between the temperature of hot and cold junction is 30. So how you can identify the temperature of hot, like, so cold junction, we normally place this cold junction in a melting ice. What is the temperature of the melting ice? So the temperature of the melting ice is 0. And this voltmeter record 3 volt. So voltmeter record 3 volt. So 3 volt means that the temperature difference is 30 degrees. So if the cold junction is in a melting ice, which is 0, so what is the temperature of the hot junction? So the temperature of the hot junction is 30 degrees. So this is how a thermocouple work. In a cold junction, we can place any object of known temperature, but normally we place ice. Why we place ice? Because when we place ice, so the difference in the temperature will be same as the temperature of the hot junction. Otherwise, if there was any other object at a cold junction, so the difference in temperature will be the temperature of the cold junction, and according to this it's 30. How I know this is 0 degree? Because I place a melting ice. So when I place a melting ice, the temperature of a melting ice is 0. So cold junction is placed in the melting ice, and hot junction is located at a place where we are recording a temperature we don't know. If it is record, it shows 3 volt. So 3 volt means that 30 degrees the change in temperature between hot and cold junction. So cold junction at 0, so hot junction will be at 30 degrees. Look, I'll repeat what we did in this thermocouple. We have a voltmeter, 2 wires which are coming out from the voltmeter made up of same material. So you can say copper is there. This will be also copper. And it is not necessary that 1 volt equivalent to 10 degree. It vary from different thermocouples. So example, in this example, 1 volts is referring to 5-degree change in temperature. The 2 wires are connected by another, example, iron, and we have 2 junctions. The point where the 2 wires will intersect, we call that as a junction. At one junction, I place inside a melting ice. Reason to use a melting ice, so that the temperature is 0 degree centigrade. Okay. And I want to record the temperature of the wall. Like this is a wall, I want to record the temperature. So I attach this junction. I attach this junction to a wall. I want to measure a temperature. And when I connect this, it records 30 volts. So what is the temperature of this? Is where we place the ice, that's a cold junction, and where the unknown substance X is there, that's a hot junction. So what is the temperature of this wall? So if 1 volt is equals to 5 degrees, 30 volts is equals to X degrees. Because if 1 volt is equals to 5, so 30 volt is X. So when I cross multiply, you can see the X, the temperature will be 30 multiplied by 5. 3 multiplied by 5 is 15 and 0 is there. So 150 degree centigrade. So what is the temperature of this? The temperature is 150. How you will know how much degree for each volt? That will be given in the question. This scale, the first value will be given in the question. Yes, at one junction, you should know that at one junction, there should be a substance of a known temperature, and other side, it should be unknown. If I use all the wires made up of same material, this thermocouple will not work, because what this voltmeter is recording a difference in energy between the particles at one end and the other end. But if you use the same material, there will be no difference, because what happened when the particles travel through a copper and the particles travel through the iron, so they have difference in the energy, and that is recorded by the voltmeter. If you use the same material, then this thermocouple will not be effective. This 30 volts, I give this 30 volt, but it can be any other number according to the question. Is it clear, this part? The working of a thermocouple?
Sir?
Yes.
So can you just say the importance of the iron wire as
What
well?
is the importance of the iron wire? Because look, what this voltmeter is recording, a difference in the energy between, like, because the particles are moving, voltmeter always record the difference in energy. So what happened? The particles are moving through the copper wire and the particles are moving through iron wire. There is one property which is called resistance of the wire, and that resistance of the wire changes the energy of the particle when they're flowing through the metal. So this voltmeter is recording a difference in energy. Like example, when the particles are moving through a copper wire, example, they have 80 joules of energy. When particles are moving through the iron wire, they have, say, 110 joules of energy. So what is the difference in energy which the particles carry when they move through a copper wire and iron wire? That is 30 joules. So that's why it is showing a 30. But if I use the same material, like if I use this wire also, I will use made up of copper. Like I'm using all the wires made up of same material. So this copper will also have 80 joules of energy transfer the particle. So what is the difference in energy of the two wires? That's zero. So this voltmeter will not work. It will only show zero. That is why this wire, which is connecting the two junctions, made up of different material. Is it clear?
Yes, sir. Thank you.
So the voltmeter, if I will use all the wires made up of same material, so the energy which the charges carry from one point to another will be same. So the voltmeter record a difference in energy, but there is no difference in energy. That's why if I use the same wire, it will record same zero. Any temperature is there, it will always record zero. So for thermocouple to work, the wire which is connecting the two junctions made up of different material. If I'm using these wires made up of iron, then the third one should be copper, or any alloys. Alloys can also be used. We can use a boiling water at a hot junction to find unknown. Yeah, that can also be done. That's true, correct. If we want to, because it's just the idea is that one of the junction, no, it is not necessary that actually it's hot and cold is not because of the you can say temperature. It's a comparison. Like when I'm comparing, for example, I'm giving another example. It is not necessary that you take a melting ice. You can take a substance with a known temperature. I will give you time to take the screenshot because I'm explaining the same idea. So you can take screenshot from this one as well. So example, this one is copper. This one is also copper. And here I use iron. And now I'm using a boiling water here in a container. Pure boiling water. And what is the temperature of a pure boiling water? That's 100. So that's a known temperature. And if I say the scale is that 1 volt stands for 10 degree. And you have an object here which is 300 degrees centigrade. So when I compare them, so what it shows, according to comparison, this is a cold, this one is hot. But even though 100 degrees not in terms of temperature, 100 degrees not a cold, but it is comparison between the two temperatures. So lower temperature is known as a cold junction. So you can take a boiling water, according to if the other substance is higher than the boiling, you can take a boiling water and record the temperature. What will be the voltage here? What will be the voltage? What this voltmeter will record? Because the temperature difference is 200. So as the temperature difference is 200, this voltmeter will record 20 volts. Because 20 volts equal to temperature difference. It shows a temperature difference, not the temperature of the. Yeah, that's why 200 by 10, that's equal to 20 volts. Is it clear? The thermocouple. Now, what could be the advantages of thermocouple over a liquid in a glass thermometer? Like instead of using a normal thermometer, liquid in a glass thermometer, what's the advantage of using this thermocouple? Any idea? Yeah, it is faster, like rapid. So faster or rapid change in temperature can be recorded, or responsive, you can say. And liquid in a glass thermometer is using a liquid. That's also right. Wider, responsive, wider range of temperature. Why wider range of temperature? Because it is a solid. So solid having a greater difference between their melting point and boiling points, and it remains solid. Yes, accurate, sensitive. It is highly sensitive because even small change in temperature that can be recorded. Yeah, that I mentioned, it can measure a higher temperature than liquid, or wider range of temperature can also be recorded. What might be a disadvantage of thermocouple? If you are using a thermocouple, what might be a disadvantage? Difficult to set up. That's one thing. Expensive. Yes, comparison can be done in terms of cost. Large amount of space. If you check the latest thermocouple, you don't find it is taking a large amount of space. Your required calculation complex. Yeah, boiling water or melting ice, there should be a, in a surrounding, there should be a known substance with a known temperature should be there. The thermocouples are no thermocouples, instead of using in a lab, normally uh, experiments outside are also used. They carry a battery. A small battery can also be used to power these thermocouple. Measuring a temperature of even the molten lava, thermocouples are best in use. So about the thermocouples, when they ask like explain working of a thermocouple, so what you will write, the working of a thermocouple. The difference between hot and cold junction, the temperature difference, produce voltage which can be used to determine the temperature. So that's, if 2 mark question is there, explain the working of a thermocouple. The temperature difference between hot and cold junction produce voltage which can be used to determine the temperature. How it is used, what will be the temperature, that you don't have to mention. And the second common question you will find, they ask draw a label diagram of a thermocouple. So what is the label diagram? A millivoltmeter, no, because the voltage is very small. So normally a millivoltmeter is used. The two wires coming out from the thermocouple made up of different material. Two wires coming out from the meter made up of same material, and the wire connecting is another material. One is known as a hot junction, and the other one is a cold junction. You can label, like the first one is copper, iron. I'll do some questions related to this thermocouple as well. So you will see how the question is there. And this one is voltmeter. So we can use it to record the temperature even in negative values and positive values, because if we have a zero center voltmeter, a voltmeter can be a zero starting voltmeter or a zero center. If it is a zero center voltmeter, so initially it is at zero mark. But for example, when you connect hot and cold junction, if the negative value of the voltage, it means the temperature is less than zero. If positive value of the voltage, it means the temperature is more than zero. So example, you are using a millivoltmeter, zero center millivoltmeter, which shows -2. And the scale is that 1 volts stands for 10 degrees. Here you place a melting ice. So melting ice temperature is 0. If this millivoltmeter shows 2 volts, so if it shows 2 volts or 2 millivolts, what does it mean? It means the temperature difference is 20. But because it is showing -2, so if it's showing -2, so the temperature difference is -20. So if the temperature of the melting ice is 0, temperature of this cold junction will be -20. So using this, you can also identify negative temperature. Only the difference will be, if the temperature is negative, the voltage will be negative. If temperature is positive, above 0, voltage will be positive. Is it clear? You can take the screenshot now. So working of a thermocouple and the label diagram for thermocouple. Voltmeter, yeah, if a zero center voltmeter is there, it can show a positive and negative voltage. Actually, the negative voltage shows the direction of the movement of the charges is opposite.